You have 250 meters of fencing. Find the maximum possible rectangular area. So let's draw a rectangle. We have x as our possible side dimension, and we have y as our possible vertical dimension. And we know that the perimeter is 250 meters. Now what else is the perimeter? The perimeter is also 2x plus 2y. So the perimeter 250 is 2x plus 2y. We have one very important equation. Now let's focus on the other important equation involving area. Area equals x times y. This is our second equation. Let's simplify this first equation by dividing by 2. We have half of 250, which is 125, equals x plus y. And we want an equation involving area and x. So let's isolate for y so we could substitute it in later. So we have y equals 125 minus x by throwing this positive x over. And we're going to substitute this y value into the second equation. So area equals x times 125 minus x. And using distribution, x times negative x is negative x squared, and x times 125 is positive 125x. And this here is a parabola. This negative sign in front of the x squared means we have a sad face. And this factored form reveals the fact that the critical points are at x equals 0 and x equals 125. Because when x is 125, we get 125 minus 125, which is 0. So we have a sad face that looks like this. Now to find the maximum area, we take the halfway point between 125 and 0, which is 62.5 as our x value. Another way of solving the x value in which we have the maximum or the vertex is to use the formula x equals negative b over 2a. Our a value is negative 1 and our b value is 125. So x equals negative b over 2 times a, which is negative 1. Two negatives cancel out. We get 125 divided by 2, which is also 62.5 as our x value. So we know that x equals 62.5. We also know that the area formula is right here. So the area equals negative x squared, which is 62.5 all squared, plus 125 times 62.5. Using our calculator, we calculate the area to be approximately 3,906.25. You have 1,000 meters to fence off your plot of land, which is adjacent to a lake. So fencing is only used on 3 sides of the property. What dimensions should be used to maximize the area of your land? So let's draw this. We have some water on one side. We have 2 y values for the fence as well as an x value. And so we have no fence on the water. So the perimeter is 1,000 meters, these 3 sides, and it consists of x plus 2y. This is our first equation. And our second equation to calculate the area is a x times y. The area of a rectangle is the base times height. Now let's isolate for y from equation number 1. We have 2y equals 1,000 minus x. And we divide both sides by 2. And now let's substitute into the y here. So we get area equals x times, we have y, which is this expression here. We can even split this up into 2 fractions. 1,000 divided by 2 is 500. And we have negative x over 2. So this here is the area formula. Using distribution, we have x times negative x over 2, so the area equals negative 1/2 x squared, and x times 500 is plus 500x. And the line of symmetry formula is x equals negative b, or negative 500, over 2 times the a value, which is negative 1/2. 2 times negative 1/2 is negative 1. And two negatives become a positive, so x equals 500. And when x equals 500, the area is 500 times 500 minus 500 over 2. So we get 500 times 500 divided by 2 is 250. 500 minus 250 is 250. So the maximum area is 125,000 meters squared. Now, to find the minimum possible area, we could sketch this parabola and figure out what the lowest possible a value is, or we could just use your common sense. If we have 1,000-meter fencing, we could set y equals 0. So essentially, we'd have a very, very long line and just make y so small that it's insignificant. And the x value would be 1,000 meters. So the area, if there is no vertical height, is 0. So using Desmos, we see that this area formula, x times 500 minus x over 2, appears to be correct on Desmos. When x equals 500, the area is 125,000 meters squared. So the maximum y value is 125,000, or the area is 125,000, and the minimum area is when x equals 0. The area is still 0. Although we like the idea of having more land, a greater area, in the context of this problem, you may be willing to sacrifice some area for having a beachfront view of the water.